write a C program to implement queue using linked list. This program is not the journal program. It is a practice program. You may get this program in the theory exam for 5 marks. Okay, so this is also important for the point of theory examination. It may come for theory exam. Okay. So we have already studied the queue. So what is queue data structure? Queue data structure is a data structure in which insertion and deletion of the elements takes place at two different ends. Insertion takes place at the end called as rear, and the deletion takes place at the end called as front end. Okay, so that particular concept we have to implement, that is queue we need to implement using the linked list. Okay, now, so what are the first statements here? Initially, we are creating a node, struct int info and struct node star next. Means two fields we are creating in the linked list, that is in the node. The first part is called as info, second part is called as next, which will contain the address of or the reference of the next node in the list. Here the list is queue. Okay, then next we are declaring the pointers of the type struct node. So temp, new node, front and rear. So here the front and rear two pointers are essential in order to point to the two different ends. Front will be pointing to the position or the address where the deletion has to be taken place, and whereas the rear will be pointing to a position where insertion has to be taken place. Then next int ch, then system clear rear equal to null and front equal to null. So initially the values of this rear and front will be having the null value. So let us try to trace the program simultaneously. So rear and front both will be having the values as null. Rear and front both will be having the values as null. And here I have just marked as certain placeholders where the info means info of that particular node and next means the next field of that particular node. Okay. Initially both rear and front will be having the value as null, indicating that queue is empty. Okay. Then next. Then again next what we have, the in the while condition one is there, so all the time the condition will be true and it will be displaying these operations. Okay, so these operations here means when we execute how it works. So let us try to execute. It will display these values. Okay, then next. So here if I try to delete, what happens? Now I'm choosing the value as 2 and then it displays queue underflow. Then if I choose the option as 3, queue is empty. Let us try to check how these particular statements are getting executed. So when I choose the option 2, what happens in the program? It will enter to the switch case, where the switch, it will take the case value as 2. So it comes over here. What is the first statement? If front is equals to null. So let us try to check what is the value of front. Front is having the value as null. So the condition becomes true. This condition becomes true and it will print queue underflow message. It will display queue underflow message because there are no elements in the queue. Queue is empty. And if you try to perform the deletion operation, then the operation will be, the condition will be queue underflow. So this statement will be displayed and then it will go to the break case. So the break means the switch case will come out, then again it will display the all the menu items. And then what I did, I entered the option that is choice as 3. So during that time it displayed again queue is empty. So let us see what happens here. When I enter the option as 3, it will go to the case 3. In the case 3, what we have? The statement if front is equals to null. So what is the value of front now? The front value is also null. Front value is also null. So it will again, this statement is true. So queue is empty will be displayed. Because the queue right now, the queue is empty because both front and rear both are pointing to null. And then again break will execute. So it will skip the switch condition Then again, it will go back to the file condition. Okay. Now let us try to insert the elements now. Say now I will choose the option as 1. It is asking enter the element to be inserted. So let us say 10. So it says 10 is inserted. Now let us see how these particular statements works. So when I have chosen the option as 1, so what happens in the program? It will go to the case 1. Okay. In the case 1, what is the first statement? Statement is new node equals to struct node star malloc size of struct node. So dynamically create a new node of the type struct node. So what it will do, it will create a memory location. So this memory location will be created. Say the memory location, the address of this particular node is 1000. That 1000 is getting the memory location I'm marking over here for the new node. Then next statement is what? Enter the element to be inserted, scanf new node info. So whatever I'm going to type here, that 10 value, it is getting stored into where? It is getting stored into new node of info. Since this is the new node whose address is 1000, so 1000's info is here. So that 10 is getting updated over here. Okay. Then next is the if condition. What is the condition here? Rear is equals to null. Is rear is equals to null. So let us see what is the value of rear. Rear is having value as null. So the if condition becomes true. Rear is null. So null equals to null. Condition is true. So if condition becomes true, then it will enter into the its if block. So in the if block, what we have? Rear is equals to new node and front is equals to new node. So both rear and front will be getting a new value, that is address of the new node. So address of new node is what? Address of new node is 1000. So now rear is here and front is also here. Okay, rear and front both are pointing to the 1000 location. So this date I will delete here. So both rear and front both are pointing to 1000. Okay, then next. Since this condition was true, it will skip the else part. Then next is what? Percentage D is inserted. That is new node of info. New node of info is what? 10. So it says 10 is inserted. So let us see again, try to insert one more element. So I will choose the option as 1. Then this time I will enter the value as 20. So 20 is inserted. So how this particular statement works here, let us see. So now rear is pointing to 1000 and front is also pointing to 1000. So when I choose the option 1, what happens? It will go to the case 1. The first statement is what? Creation of the new node, that is memory creation dynamically. So what will happen here is that it will create one more node. Say that 2000 is its address. And whatever the value we type, that 20 is getting stored into the new node of info. Okay, then next. The next statement is if rear is equals to null. So here, what is the value of rear? The value of rear is 1000. So is it equals to null? No, the condition becomes false. So this if condition become false means it will skip these lines. Then it will go to the else block. So in the else block, there are two statements. What is the first statement? Rear of next is equals to new node. So rear of next means what? Rear is pointing to 1000. So 1000's next is what? This value. So in rear of 1000, what we have to update? We have to update new node. So new node is what? It is 2000. So 2000 I am updating over here. What it says? Rear of next is equals to new node. Rear is 1000. So 1000's next value is here. In this one, what I have to update? The address of new node. Address of new node is 2000. So 2000 will get updated over here. Okay. Then next statement is what? Rear is equals to new node. Rear equal to new node means the rear pointer should now contain the value as what? 2000. Meaning this rear now it will be pointing to 2000. Rear will be pointing to 2000, whereas still the front is pointing to 1000 itself. So we made these two we executed these two statements. Then after this one, what is the next statement? Printf, the new node info, that is 20 is inserted, message will be displayed. So now we could able to insert two elements here. If you notice here, what we are trying to do, we are inserting at the rear pointer. Wherever this rear is pointing, at that particular position, we are inserting. Let us try to insert one more element here. So when I again choose the option as 1, I will choose the option as 1 here. Then let me choose the value as 30. It says 30 is inserted. Now 30 inserted means what happens here? Again, these statements will execute. First statement is what? Creating the memory location, then taking the value that 30. Okay, then now when I say the 30 is there, that 30 will be, first step is what? Creating the memory. So memory will be created, then 30 will be added into that info, and then the next part is what? New nodes next will be getting updated as null. That is, this value will be what? Null value. Okay, so did we miss updating in the previous case? Okay, so here it was null, so this will get updated as null. Okay, then next case statement is what? If rear is equals to null. So what is the value of rear now? Rear value is 2000. So this condition, that is if condition, is false, so it will skip this statement. Then the else part will come. In the else part, what we have? Rear of next is equals to new node. Rear of next means what? Rear is 2000. So 2000's next value is what? This value, that is null. In this place, what we are going to update? We are going to update the value of new node. So what is new node? It is nothing but 3000. So 3000 will get updated over here. So 3000 will get updated. Then second statement is what? Rear is equals to new node. Rear is equals to new node means, so now rear will be having the new value, that is 3000. So rear will now point over here. Okay, so the rear we are incrementing every time whenever there is a new element is inserted. Okay, then now let us try to see the display part here, how the display part works. So display, for the display, if I choose the option as 3, it is going to display what? 10, 20 and 30. Okay, now let us see how this particular function or the operation works here. So at present, rear is 3000, it is pointing to 3000 memory location. Front is pointing to 1000 memory location. Okay, now when we choose the option that is 3, it will go to the case number 3. In the case 3, first statement is what? If front is equals to null. What is the value of front now? The front value is 1000. So is it equals to null? No. This if condition becomes false. Then it will go to the else part. In the else part, what is the first statement? Q contains. So first, that is Q contains message will be displayed. So it will display a message stating that Q contains. Then next statement is what? Temp is equals to front. We are taking a temporary pointer which will have the address of front. So let us take one temp, and what this temp will be storing? Temp will be storing whatever the front is having. Front is having 1000 value. So 1000 is created over here. That is 1000 is assigned to the temp. Okay, then next statement, while temp not equals to null. So we are running through an iterative statement, that is while, and the condition is temp not equals to null. So what is the temp value? 1000. Is this 1000 not equals to null? Yes, 1000 is not equals to null. Condition is true. Then it will enter into the while loop. In the while loop, there are two statements. First statement is what? Printf statement. In the printf, what we're trying to print? Temp of info. So temp of info means temp is having 1000. So 1000's info is what? 1000's info is 10. So that 10 will be displayed first. So 10 will be displayed. Then next statement is temp is equals to temp of next. So temp of next means temp is 1000, that is 1000. 1000's next is what? 1000's next is 2000. So now temp is getting re-updated as 2000 value. So now it will be 2000. Means now temp will be pointing to the next node. Okay, then next, since it is in the while condition, it is in the while loop, condition is what? Temp not equals to null. So temp is having 2000. Is this 2000 not equals to null? Yes, 2000 is not equals to null. Condition is true. Then what happens? Again, these two statements will be executed. First statement is was print temp of info. So temp is 2000. 2000's info is what? 20. So 20 will be displayed. Now 20 will get displayed. And then next is what? Statement temp is equals to temp of next. Temp is pointing to 2000. Next value is what? 3000. This 3000 will get updated to what? Temp value. Now it will get 3000 as the value. That means now temp is pointing to the next node. Okay, then again it will go into the condition. The condition is temp not equals to null. So now this time the temp value is what? 3000. Is this 3000 not equals to null? Yes, 3000 is not equals to null. Condition is true. Then it will again go through these statements execution. First statement is temp of info. Display the value of temp of info. So temp is 3000, meaning the 3000's info, that is 30. 30 will be displayed. Okay. Then second statement is what? Temp will get updated as temp of next. Temp is pointing to 3000. 3000's next value is what? Null. So this null will get updated to what? Temp value. Now the temp becomes null. Temp becomes null. Again, it will go to the while condition. The condition temp not equals to null. So now the value of temp is null. Null not equals to null. Condition becomes false. Since condition becomes false, it will come out of the while loop. So while loop, it will skip. Then the next statement is next statement. So it will skip the switch case, that is execution. So at the end of this case number 3, what it has done? Q contains 10, 20, 30 will be displayed. So in the program also you could see Q contains 10, 20, 30. After that, again it will display all the operations. Now here, suppose if you try to, if you want to delete means it has to be deleted, node has to be deleted from the front end. So now if I choose the option as 2, 10 is deleted. Okay, why 10 is deleted? Because front is pointing to what? This location, that is, it should delete the value 10. Let us see how this particular execution works. Okay, so as of now, we know that the temp rear is pointing to 3000, front is pointing to 1000. These are the values of rear and front. When I choose the option as 2, what happens? It will come to the switch, that is case number 2. The case number 2, first statement is what? If front is equals to null. What is the value of front here? Front value is 1000. So 1000, is it equals to null? No, condition is false. Then it goes to the next part, that is else if. So in the else if, what is the condition? Is rear is equals to front. Okay, so what is the rear value? 3000. Is this 3000 is equals to front, that is 1000? No, 3000 is not equals to 1000. So this condition, that is else if condition, is also false. Then it goes to the else part. In the else part, what we have? Four statements. What is the first statement? Temp is equals to front. So we are taking a temporary pointer. Okay, say that temp, which will have the value of front, that is 1000. We are taking a temp which will have the value of front. Then next is what? Front is equals to front of next. So what is front? Front is holding 1000. 1000's next value is what? It is 2000. So now front will get a new value as 2000, meaning that front now it will point to the next element, point to the next element or the next node. Then next statement is printf %d deleted, that is temp of info. Temp is what? 1000. that is here. 1000 info is what? 10. So it will display 10 is deleted. 10 is deleted. After that, the next step is free temp. Free temp means temp is pointing to 1000. So dynamically remove this memory location, that is 1000 memory location. So this will get deleted. It will get deleted. So what we could do here, we could successfully delete the element which is placed at or which is pointed by the front. So now our queue contains what? 20 and 30. The first inserted value was 10, that is being deleted. Next time if you want to delete, then this 20 will get deleted. Let us see how this 20 will get deleted. Okay, now again I will choose the value as 2. It says 20 is deleted. Okay, now let us see in the program how it works. Again, when I choose the option 2, it will come to the case 2. In the case 2, the first statement is what? Front is equals to null. What is the value of front now? The value of front is 2000. Is this 2000 equals to null? No, it is not equals to null. So if condition is false, then it goes to the else if part. In the else if part, what we have? The condition is rear is equals to front. Rear is equals to front means rear value is 3000, front value is 2000. Are they equal? No, they are not equal. So the condition becomes false. Then it goes to the else part. In the else part, again, there are 4 statements. First is what? Temp is equals to front. Equal to front means now the temp will get a new value, that is whatever the front is pointing, that is 2000. So temp now will be 2000. Okay, then next statement is front is equals to front of next. Front is having 2000. 2000's next is what? 3000. So now front will also point to the 3000 location, that is here. So front is now pointing to 3000 location. The next statement is printf percentage d is deleted. What? The percentage d here is temp of info. Temp of info means temp is pointing to 2000. 2000's info is what? 20. So it gives the message or it prints 20 is deleted. Okay. Then next statement is free temp. Free temp means the whatever the memory location this temp is pointing, that is 2000. This memory location you dynamically delete it. Dynamic delete means this will get deleted. This will get deleted. Now what happened? We could successfully delete which is being pointed by the front. So 20 is now deleted. Now what we left in the queue? In the queue what we have is the only one element, that is 30, in which rear and front both are pointing to the same memory location. Now again, if we try to delete the element, suppose if I choose 2, okay, then it says 30 is deleted. 30 deleted means how it works? Again, when I choose the option as 2, it will go into the case 2. In the case 2, the first statement is the if statement, wherein the condition is front is equals to null. So front equals to null, is this condition true? Let us check. Front is having what value? 3000. Is it equals to null? No, it is not equals to null. So the if condition is false. Then next statement is what? Else if. In the else if, what is the condition? Rear equal to front. So let us check what is the status of this condition. So rear is equals to front. Rear is having 3000. Front is also pointing to 3000. That is rear equal to front. This condition is true. So now this time this condition becomes true. So since this is true, it will go through these statements. What is the first statement? Temp is equals to front. Okay. Again, now temp is going to have the new value, that is front value, that is 3000. So now temp will be pointing to 3000. Then next, front is equals to null, rear is equals to null. Front and rear both will have the value as null. So now rear as well as front will get updated to the values as null value. Okay. Then next is what? Printf percentage d is deleted, that is temp of info. Temp of info means temp is pointing to 3000, that is 3000 memory location. In this, info is what? 30. So it will display a message 30 is deleted. So once that message is displayed, the next statement is free temp. Free temp means the 3000 memory location you have to delete dynamically. So this particular location will get deleted. Okay. Since why we updated rear and front equal to null? Because we could identify that there is only one element present in the queue. When we try to delete that one, then queue will become empty. When queue is empty, then rear and front both should be having the value as null. So we updated front and rear as null value. Now this time again, if you try to delete the element, so since it is empty, the message will be queue overflow. Even if you try to display the elements, that is 3, option 3, it will display message as queue is empty. So like this, the dynamically we can implement the queue data structure using linked list. Again here in this particular concept, there will not be a concept of queue overflow because the size is not predefined here. The new elements will get added as and when the program executes in the runtime. So there will not be a question of queue overflow concept. Students, is this understood?
Yes, sir.
Yes, sir.
Yes, sir.
Any doubts?
No, sir.
No, sir.
Okay, so this concludes the unit number 5 and as well as the entire syllabus of the data structure. If you are having any doubts, you may ask. We still have some 5 to 6 minutes. If you are having any doubts, you may ask here. So related to the examinations, okay, as of now, few students were asking for the meeting that what about the exam schedule? So exam schedule is that exam timetable is not yet finalized. Okay, you will be definitely getting minimum of 10 to 15 days prior intimation about the exam timetable. So you no need to worry about the exam timetable. As soon as we receive, we will be forwarding you the circular related to the exam timetable. Definitely you will get 10 to 15 days of well in advance. Okay. So you may start studying for the exam. You no need to stop the studying until you get that timetable. So you can start that study. If you find any difficulties related to the data structure concepts, you may personally contact me on my mobile number. You just put a WhatsApp message or you may call. I can clarify your doubts. Okay, so shall I consider the syllabus as completed?
Yes, sir.
Yes, sir.
Yes.
So what is the feedback on this particular online teaching? So could you able to follow it or you faced any problems?
No, sir. Only network issues sometimes.
So
Network issues.
only network issues.
Yes. Even I face certain network issues on some days due to network bandwidth problems. Yeah, Zoom will be having. It requires minimum of 1 Mbps bandwidth. So if we have that much of network, then there shouldn't be any problem. Okay. Any other feedback apart from network issues?
Extraordinary, fantastic, mind-blowing, sir.
What network issues? Pranay? So all those feedback was for the network issues.
Sir, that's for the online classes.
Okay, fine. So I wish each one of you to excel in the not only in data structure, in all other subjects, study well, okay, and do well in the examination. If you find any problems with respect to the concept, you may reach me anytime. Okay.
Yes, sir.
Shall we conclude?
Yes, sir.
Okay. I hope that you have written the with respect to the journal programs. You have written the write-up part of all 20 programs. Yes.
Yes, sir. Yes, sir.
Yes,
If you are
sir.
not written, you may complete it writing the write-up parts, and as soon as the college reopens, you may execute the remaining programs. Okay? So there shouldn't be any delay in writing the write-up parts. Those who have the computers or the laptops at home, you may practice the programs.
Yes, sir.
Yes, sir.
Okay. So we'll conclude.
Yes, sir.
Okay.
Yes,
Take care. Be at home. Be safe.
You too, sir.
Yes.
Bye, sir. Thank you.
Bye bye.
Thank you,
Bye,
sir.
sir. Bye, sir.
Thank
Thank
you.
you, sir. Thank you, sir.